Okay, here's page 2 of the exam. Since many students missed this on their Module 1 exam, I wanted to re-emphasize that we have f of x equals 4 to the x power minus 1. Notice that x is the exponent. Anytime that x is an exponent, it is an exponential function. Now that we've been working with exponents, hopefully you'll be able to make a stronger connection. Anything where the highest power or highest exponent is 2, I probably should make this a little bigger. Anytime the exponent is 2, it is quadratic. Anytime there's exponent is 1, it's linear. Remember that sometimes you may have to do some distributing if it's not in these exact forms. For example, you may be given something like x minus 1 squared plus 6. Because of this squared, this x is going to end up being squared and it's going to be quadratic. You're going to need to know that this type of graph is exponential. This graph here is actually cubic. It's none or neither. The next 3 problems, actually I even put a little, I put a little quadratic parabola function picture. You see it right there. So if you see a parabola, think quadratic. So for the next 3, I'm going to get up and make sure you can see this in the video. For the next 3, I found the common difference, the common ratio, and a second common difference. For this first row section for number 16, 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 4 is 15, and so on. I only have one common difference, so it's linear. And think back to this problem up here, 2x to the first power, linear. This next one was exponential. It's times 4, all the way down. I checked them all. Anything that's exponential or multiplying by a number is exponential. And if you forget that, I do have a poster on the back by my Hogwarts poster. It says geometric is r to the x times f of 0. I'm going to put exponential above that as a little hint. This last one, we have one row where the numbers are not alike. And so I tried the second time. And this time I get x plus 2 all the way down. Because I have a second difference, it's quadratic. Again, another connection. X squared, quadratic. 2 differences, quadratic. Now linear equations for domain and range, unless there's a constraint, would be negative infinity to infinity. Remember, domain, we're looking at the x-axis from left to right. X-axis, left to right. For the range, bottom to the top, we're looking at the y-axis. Okay, so negative infinity to infinity and negative infinity to infinity for this equation. And you can actually put it into your graphic calculator and graph it so you can look at the picture. Do the same thing for 5 times 2 to the x. I'm just going to get my calculator because I want to show you at least the graph for the next function. Actually, I will do the third function first since it's already in my graphing calculator. This one is a picture of f of x plus 5 squared minus 8. It's this one right here. Okay, looking at the x-axis going left to right, it's coming from infinity and going to infinity. It's going to cover every single piece on that x-axis. Then going from bottom to top, looking along the y-axis, it actually starts at negative 8 and goes up towards infinity. So for my function, I put negative infinity to infinity for the domain, and then -8 to infinity for the range. Notice I put a bracket here because it does start at this 0.8. It's actually a point on the graph. So now I'm going to push in the middle one, number 18, 5 to the x power. Trying to get it. Getting the parentheses, okay. Oh, it didn't work. Okay, clear. 5 to the x. Oh, I gotta look at it. Okay, yeah, 5 times 2 to the x. Okay, 5 parenthesis 2x parenthesis graph. Okay, so it's starting to graph. There we go. So going from left to right, it's coming from negative infinity and it's going to go up to infinity. So that's what I put for the domain, negative infinity to infinity. And then it goes very close to 0. It looks like it's touching 0 here, but really it's not. It's just getting very, very close to 0, and then it's going to infinity. So from 0 to infinity is what I put, and I put a parenthesis there because it's not really touching 0. And this is something you need to remember for exponential functions. Now the third part, or second half of this, is a little more complicated to show you. Let me see how much video was gone. I found that uploading shorter videos works. Okay, that took 7 minutes. I'm gonna do another one.